Hey, welcome to physics, but some of you are wondering what the heck is physics. If you ask me to give you a definition, I'm going to steal a definition that my college prof gave me in first year physics. My college prof said, physics is the science of measurement. Have to set up my pen, I'll do that later. Get rid of that screen. The science of measurement. It means, first of all, I like the definition because it's pretty broad. It means if you're measuring something, you're doing physics, which covers almost everything. But it also leads to a question. Maddie, what do we measure? In Physics 11, three main things. We measure time. Does anybody know what the SI, System International Standard Units for time are? What do you measure time in? Yep, seconds. No, seconds. Not minutes, not hours. If they give it to us in that, we convert it. We measure length. Come on. What are the SI units for length? Nope, not centimeters. No, inches? Oh, please, go back to the US. Meters. Which in Canada is spelled RE. And mass. Measured in kilograms. And now I'm going to start to abbreviate. I tend to abbreviate. See, I did, no, nothing, okay. In fact, in physics, there are science, there are 7 quantities, 7 things that are defined, and everything else is based on these 7. We have 7 base quantities, and these are defined very, very meticulously, very, very carefully, and everything after that, we base on these 7. So we have length, which was meters. We have time, which was seconds. Abbreviation for meters is a lowercase m. Abbreviation for seconds is a lowercase s. We have mass measured in kilograms. The 4th unit that is defined is current, electric current. Does anybody know what the units are for electric current? You probably did it back in Science 9 back in the day. Take a guess if you're not sure. Ohms? Nope. Ohms is resistance. Ohms is defined in terms of current. No, you're right. What? Amps. Symbol, capital A. Named after a scientist whose last name was Ampere. Did a lot of work. Watts is defined in terms of current and voltage. And voltage is defined in terms of current and time. Temperature. What units do we use for temperature?
Kelvin.
What?
Kelvin.
What? My first name is Kelvin. Yes, my first name is a science unit. It's degree. Oh, boy, I got to toggle some of this off. It's degrees Kelvin, usually written degrees lowercase k. I'll explain a bit in the next graphic. Then there is the amount of a substance. You won't, by the way, we won't be getting to anything past kilograms this year, although we'll be doing other units, but everything is going to be something based on meters and seconds and kilograms. Physics 12, we look at electricity and magnetism, but we don't do heat in the BC curriculum, so you're not going to see degrees Kelvin. Amount of a substance we won't look at in physics, but you will look at it in chemistry. Does anybody know what the amount of a substance is in chemistry? Mr. Perugia has it hanging from his ceiling, if you've had Mr. Perugia. Yeah, moles. Abbreviation MOL. Those are the first 6. I think the 7th one is my favorite because it's the only one that as soon as I give you the name, you'll know how big it is. If I tell you meter, you don't know it's about yay big. You have to have seen a meter stick to figure that out. If I say to you second, you don't know that it's about that long. You have to have seen a watch for a while and internalized that. But this one here, as soon as I tell you the name, you'll know exactly how intense that light is. We measure light intensity in candles. And yes, one candle is exactly as bright as you're thinking right now. Hopefully you all have an image of a candle in your head. Yeah, that bright. It's actually candelas, but we're not going to look at that anyways this year. I love nerd humor. So, easy way to compare temperature. The US still uses Fahrenheit. So if it's 0 degrees Fahrenheit, that's really cold outside. If it's 100 degrees Fahrenheit, that's really hot outside. In Celsius, if it's 0 degrees Celsius, that's pretty cold outside. Water will freeze at 0 degrees Celsius. What does water freeze at in Fahrenheit? Yeah, 32. What a stupid number. What? Oh, and 100 degrees Celsius, you're dead. And if you're in degrees Kelvin, 0 degrees Kelvin, you're dead. 100 degrees Kelvin, you're still dead. 0 degrees Kelvin is also called absolute zero. That's when molecules and atoms atoms don't stop moving, but that's when molecules stop vibrating and there's no longer any heat energy. It's about minus 272 degrees Celsius. So 100 degrees Kelvin would be about minus 172 degrees Celsius. You're not doing very well. So there's your temperature comparison. In addition, turn the page. In addition to the base units, the SI system, what some of you think of as the metric system, but it's actually the System International, the SI system, uses prefixes to allow for the expression of large and small units. Prefixes are placed in front of a base unit, and they represent a multiplying factor. Milligrams, kilowatts, megabytes. You do not need to memorize these prefixes. They are on your green sheet. Can you find where on your green sheet, back page, all of the metric prefixes are? Now, you might choose to memorize some of the more common ones because you're lazy and you get sick of looking them up. And that's the only reason you should ever memorize something, because you're lazy and you get sick of looking it up. And so once in a while, Austin, this year I will say to you, even though this is on your formula sheet, we're going to be using this 500 times in the next 2 weeks. It's worth memorizing because you're going to get sick of looking it up. That's when you should memorize something, because it's a shortcut, because it's convenient, not because you have to. So, in the middle of my chart here, this is where the base unit goes. This is where we have seconds, or grams, or meters, or amps, or joules, or watts, or whatever. You'll learn lots of units this year. So no metric prefix goes there. If you want a power of 10, you can say it's 10 to the 0, because what's anything to the 0 power? 1. So we don't multiply by anything. Okay. We're going to go up. Deci, is that on your green sheet? DECI. What power of, first of all, what's the abbreviation for that? Lowercase d, uppercase d? It makes a difference. Okay, lowercase d. And that's 10 to the negative 1, or 0.1. Yes? I'm going from memory here, but correct me if I'm wrong. I never use that. I can't honestly recall a time when I said, oh, that's 1 decimeter. I just said 0.1 meters because it's less writing. Isn't it? And clearer. So I almost never use that prefix. Centi, I only know because of centimeters. I hardly ever use that one either. Centi, lowercase c, yes? And it's 10 to the negative 2. You can also write 0.001, but it's less writing to do powers of 10. Milli will use occasionally, especially in Physics 12, milli amps are very, very helpful. A lot of current is, milli amp, 8 to 10 milliamps is nicknamed the death current. That's enough to start to kill you. And so that's usually when we start to keep track of how much current there is. So milli is a lowercase m. We already have a problem. because a lowercase m is the abbreviation for milli, and a lowercase m is the abbreviation for meters. You're going to hear me say very often, we have run out of English letters. We'll even bring in some Greek letters once in a while, but you'll have to figure out what something means based on where it's located. An m in front of another letter is milli. An m at the end of some letters, that's meters. 10 to the negative 3, yes? Why do we use an M for milli? Because milli starts with the letter, which really doesn't help us for micro. Because micro starts with the letter. We're going to pull out a Greek M. Looks like that. It's called a mu. It's called a mu. What does a Greek cow say? Mew. What does a Greek cat say? Mew. There's all sorts of stupid jokes that go along with that. Where's my mew? Oh, here's my mew. Mr. Do It. I have one somewhere. I'll have to find it. It's a blue piece of wood carved in the shape of a mew. I'll dig it up later. That is where our lowercase m came from. You can sort of see it looks like a handwritten M, but lower with a droopy tail. And micro is 10 to the negative 6, yes? That one you'll memorize in physics 12, because you'll get sick of looking it up. When we look at electricity, when we look at charge, electric charge is measured in coulombs, and we do most of our work in microcoulombs, because 1 coulomb is a massive charge. If you absorbed 1 coulomb all at once, not only would it kill you, it would probably cause you to burst into flames and things would melt, and it would almost be one of the horror movie skin melting deaths. Not so we don't deal with coulombs, we deal with micro coulombs. Nanotechnology is currently the rage. Lowercase n, yes? And that's 10 to the negative 9. I used to stop there when I first started teaching physics, because that was as small as we had gotten about 15 years ago. I've slowly had to broaden this chart in both directions. Did I give you pico on the green sheet? I did, okay. Lowercase p. And you'll notice, aside from deci and centi, which is the other reason I don't really like them, the rest go up by 3s. Because in our number system, every 3 represents 1,000 or 1,000,000 or 1,000,000,000. It's when you give it a new name, and even with decimals, we carry on that tradition. So this, I'm pretty sure, is a 10 to the negative 12, yes? Femto, lowercase f. 10 to the negative, I think, 15. Did I give you atto? Yeah. I did. Okay, I must have changed the chart because the original chart never had that. Lowercase a. When we're getting that small, we're starting to approach uselessness. There's something called the Planck length. The Planck length is the length of the smallest possible object in the universe. Things can't be smaller than that. And so, although you can make up more prefixes, there comes a point when you say, well, doesn't do us any actual use. I will later on, though, show you a femto camera. A femto camera takes a picture in 1 femtosecond, and it's so fast you can actually physically see a laser beam move across the screen in slow motion. It can take a picture and it can actually pick up a beam of light. It's fast. Let's get bigger. Deca. I've never used this one. It's also a D, but is it lowercase or uppercase? Or no, this one has 2 letters, isn't it? Yeah, stupid. What is it? A D? Lowercase d, lowercase a. And the reason is, I've never said that building is 3 decameters high. No, it's 30 meters. Makes more sense, it's clearer, it's less writing, so it's on your sheet, and I might throw it in your homework once in a while, but you'll never hear me use it in conversation or if I'm making up a question. 10 to the 1, yes? Hecto, H, lowercase. 10 to the 2. I never use that one either. I'd rather just say 450 meters, not 4.5 hectometers. Doesn't make sense to me. We do use the next one all the time, certainly when we're driving. Kilo, lowercase k. This is probably one that's worth memorizing because it's going to show up fairly often. 1,000 or 10 to the third. Yes? My first computer was a Commodore 64, and it had 64 kilobytes of memory. 64,000 bytes. Wow! It just seemed like a lot at the time. Mega. Abbreviation? Capital M? I can remember that mega is also millions because the M's go together. The only risk with that is some people might think million millions go together because they have a mill in the... I know mega is big, so mega is 10 to the 6th or a million. My first hard drive had 8 megabytes. How will I ever fill 8 megabytes? Wow! Oh, I'm saving everything now. Now memory has started to be, computer memory has started to be measured in gigs, gigabytes, capital G. Gig is 10 to the 9th, and that's a billion, yes? If you write out the number of zeros. This little external hard drive that I have on my desk here is a terabyte. So I added that about 8 years ago when I sensed that it was on the horizon, capital T. Let me know if I'm making a mistake, but it starts to go up by threes again. It's just those ones close in, which is also why I don't like centi and deci and deca and hecto. They break the pattern. Going up by threes or down by three. That's nice. I can remember that. Peta. Now they're starting to talk about Google's servers when you add them up equaling petabytes. I don't think you're going to be buying a petabyte hard drive anytime soon, and by anytime soon, I mean within the next 5 years or so, but I'll be willing to bet before you all get my age, you'll have a petabyte phone, probably. There's limits because we can only get so small, and then we start to run into something called Heisenberg's uncertainty principle, which if you're getting on the electron size of things, there's a universal physical limit to what you can do because of the universe. But, okay. Capital P. Exa. Is it on your sheet? Capital E, is it? Who names these? There's actually a committee. There's actually a committee. The next one, I think they're going to symbolize with a capital H. And the way they pick these is they look at, let me think how they do this, because it's based on hecto. They take that geometric prefix and they move one letter. They want to make, there's a movement, and it's probably not going to go over, but there's a movement to make capital H hecka. So you would have a heck of bytes, which would be kind of cool, like a heck of a lot of bytes, but we'll see. They're working on them. Any unit can be used with a prefix. For example, 1 kilogram, I just replaced the kilo with a 10 to the 3 or 1,000. Now it's grams, back to its base unit. 100 centimeters. To go to meters, I would replace the letter C with a 10 to the negative 2. If you go 100 times 10 to the negative 2, you'll get 1 meter. We will be doing some unit conversion along the way. Usually about 85 to 90% of the time, I'm going to give you the units in the correct measurement. The only issue is at the beginning, I will give you some units in kilometers and hours because that's how you measure speed in the quote-unquote real world. In physics, we measure speed in meters per second, so we'll get good at that conversion. If you go back to these 7 units that I gave you. You don't need to turn back. You may notice that one of these is different from all of the others because it uses more than one letter. This one here. This is the only one. Kilograms has a metric prefix. Meters doesn't. Seconds doesn't. Amps don't. Kelvins don't. Moles don't. Candles don't. Oh, by the way, if you want the abbreviation for candles, it's lowercase c, lowercase a, but I'm never going to ask you that. But if you're a nerd and you want to fill it in, you can. Why is that? How come? Put your pencils down, look up.